So then the next one is yet another interesting one called as K nearest neighbor. So this algorithm is one of the widely used algorithm for classification, and we can just go for clustering the data set. So now before we move further into this K nearest neighborhood, let us draw a kind of clear understanding about what do you mean by parametric methods and non-parametric methods. So here you have a table which is being shown, and here we discuss on the column I have parametric machine learning algorithms as well as non-parametric machine learning algorithms, and we give the details of this parametric and non-parametric machine learning algorithms with respect to their benefits as well as demerits, limitations. So what are the benefits of parametric machine learning algorithms? And when the problem is very small, then you don't have to use a complicated algorithm to handle that. So we have to go for a very simple algorithm. So benefits like simple to understand as well as interpret result. So then speed of learning from the data set will be very faster because you have very small data set. So you must be able to learn faster. So less training time is required because it all depends on the kind of problem domain you have. A simple problem, simple model. So you are able to do the training faster. We are able to do the learning faster. So then what are the benefits of non-parametric machine learning algorithm? So here they are a bit complicated. So they are flexible enough to fit a large number of functional forms. They are able to exhibit better kind of functionality when compared to the parametric machine learning algorithms. So necessarily, depending upon the complexity of the problem and depending upon the nature of the problem, we must be able to distinguish and then appropriately select either parametric or non-parametric. I think I made a mention earlier. So whenever we go for deciding about the model, it is very essential that we must be able to look into the nature of the problem as well as the scope of all this machine learning algorithms. So then we must be able to come to a consensus what kind of machine learning algorithm will be suitable for solving my problem. So as we talk about this non-parametric machine learning algorithms, so there is not much assumption about the underlying functions. Like as we talk about the parametric, they must learn from the observational data. Hope you remember. So when you have a collection of historical data or when you have a collection of past data, we call them as historical or observational data. So those kind of data will exhibit a trend from which the models will be able to learn the pattern. Suppose if we do not have such kind of historical data set, in such cases, still we must be able to make the system to understand the pattern hidden in that. In such cases, there is no need for any assumption about the underlying function when you adopt this non-parametric functions. Then it requires high performance for prediction, of course. Now the problem is a little complicated. The learning process is also difficult. So naturally, it has to exhibit better performance than the parametric machine learning algorithms for a complex problem. So this provides high performance for prediction. So then limitations. So choosing a function, like suppose when you talk about the functional form of a problem. So choosing a functional form constrains the method to the specified form. See here, suppose when you talk about the scope of the problem, so then as I told you, we must be able to match the scope of the problem with respect to the potential of the method that we are going to choose. So accordingly, because the problem size itself is small and the scope of the method that we are going to select also is going to match with the small problem. So it goes well. For a small problem, you have a small solution, as simple as that. So because of the small dimension of the problem, I cannot call this a small dimension, because of the limited scope of the model that we are going to select. So it has to have a limited complexity. And as I told you, it is more suited for simpler problem. So you can imagine this way, when you have a problem which is very simple in nature, and when you have to select a model which is also very simple in nature, so it goes well. So limited complexity in the problem. So we choose a model which has got a limited complexity with respect to the computation, training, understanding, and prediction. So it has limited complexity and more suited for simpler problems. So we need not take this as a disadvantage or limitation. That is the fact. Like smaller problem, smaller solutions. So it is unlikely to match the underlying mapping function and results in poor fit. Suppose when you go for a kind of, when you apply parametric machine learning algorithms for a kind of complex problem, naturally that will result in poor fit. That is because it is not matching properly. There is not a kind of a perfect match between the problem and the model. It leads to poor fit. So then coming to the limitations, it requires more training data because the kind of mechanism, the workflow is going to be complex. So that requires more training data in order to estimate the mapping function. So then due to the more number of parameters to be understood and to be taken for training, and it is quite slower comparatively to those that of the parametric machine learning algorithm. So here there is a risk to overfit the training data because the training, whenever the training happens to be very intense, then there is always a kind of danger that the model will learn perfectly about the data and hence it goes for overfitting. So hope you will be able to recollect the kind of diagrams that we discussed for underfitting, overfitting, and then good fit. So if you could recollect, and in the case of overfitting, it wouldn't leave any of the points left without being classified. It will be a kind of perfect classification, 100% classification. So because the training happens to be very intense and the model gets trained continuously on this kind of data, it may lead to overfitting. So when it gets overfit, then probably it may not work well on the new kind of data. So then when we talk about the kind of learning process, we can call the machine models to be of two categories. One we call as lazy learner and the other one is called eager learner. So this is the same as that of the kind of students that we see in the class. There are certain students who will be just taking, their own time for doing all other activities. But once the test is announced, probably they will gear up, pull up their socks and then start working for the test. And there are many students who may be prepared all along. They wouldn't wait for the test to come and they will be armored and they will be ready for test at any point of time. So you just keep this in your mind. You'll be able to understand what is lazy learner and who is eager learner. So lazy learners simply learners store the training data and wait until the testing data appears, like as students do. So on the day of announcement of the test, they just look out for the notes and they look out for learning materials and start the preparation. So how about this eager learner? Eager learners construct a classification model based on the given data set before getting the data for prediction. That is before the training, before the testing data appears. Even before that, the model will be ready, the training is being done. So these are the two different classifiers, two different aspects of learning process based upon the nature of learning and based upon the behavior of the model towards the testing as well as training. We classify them into lazy learner and eager learner. So let us move on to the next aspect of this. Next slide. So now let us turn our attention towards the core principle of k nearest neighbor. So this k nearest neighborhood algorithm is being called as is being classified as a non-parametric approach algorithm. So KNN is widely used as it is non-parametric in nature, which means that it does not require any underlying assumption about the distribution of data. So now we must be able to understand one thing very clearly. So when you have a model which requires a kind of assumption from the historical data, so we must be able to provide that kind of information in the data set. But this algorithm, interestingly, k nearest neighborhood, doesn't work on the assumption of the data set. It is going to work directly on the data set. And that is the reason why it just postpones the process of giving the result till the end. So I'll come again. KNN is widely used as it is non-parametric approach in nature, which means it does not make any underlying assumptions about the distribution of data. It doesn't just bother about what kind of data is there and what are the associations among the data and what is the trend which has been set by the data and how one data depends on the other data. No, it doesn't bother about any such thing. So then it is also called as lazy learner algorithm. The process is lazy learning because most of the work is performed at the time of classification. classification. So the algorithm is in such a way that it is able to apply the principle of k nearest neighborhood at the time of classification. So it doesn't have to have prior learning and doesn't have to have the kind of training, and hence we say that this is a lazy learner. So then in KNN classification, K is a very important point. K is the number of nearest neighbors that we are defining for the algorithm to work with. So this K is playing a very important role. So when the K number happens to be less, then the algorithm will be having less complexity. As we try to increase the number of increase the size of K, or when you try to increase the value of K, and probably that makes the algorithm complex because it has to find as many number of nearest neighbors as possible. So then let us just look into the algorithm, that is the working steps that you should understand to understand the core part of this nearest neighbor. So here we have determined the value of K, right? We have to apply some intelligence to decide about this K, like there should be some rationale as we try to select the value of K. And you will understand as you start working with the algorithm, you will try to understand and how to decide about the value of K. And also this K should have a kind of correlation with respect to the nature of the data that we are working with. And what is the variability that is present in the data, and what is the kind of distribution the data exhibits. So all those things matter when you decide about the value of K. So then you calculate the distance between the new point. Because you start with one point, we call it as a seed point. Then the algorithm will take a new point. Then it tries to find the distance between this point and the new point that it has taken randomly. So now it tries to find the distance. That the distance is being calculated by a formula called Euclidean distance. So if you try to modify the algorithm in some other way, then you can go for some other way of computing the distance, like Manhattan distance. So calculate the distance between the distances between the point that has been chosen and the new point, and sort the distances and determine the k nearest neighbor based upon the minimum distance value. So with respect to one point, you try to find the distance of other surrounding points, then we calculate the distance. So now after calculating the distance, we try to sort the distance. Now we will be able to find the data points which have the minimum distance and which have maximum distance rather. So then we try to aggregate all the points which have got the minimum distance with respect to the point that with which we started the process of calculating the k nearest neighbor. So I'll come again with step number 3, sort the distance and determine k nearest neighbors based upon the minimum distance value. So then analyze the category of these neighbors and then assign the category for the test data based upon the majority rule. So then we go in for a kind of computation. So depending upon the minimum value, we decide which of the data points will get closer, and accordingly we proceed further with respect to the new points that we take. That's how the algorithm proceeds until all the data points are processed back. So here, then we return to the predicted class. That is, we are able to come up with the ultimate objective of working on this algorithm. So k will be the odd number if the number of classes that you are aiming for is 2. This is a kind of condition that you have to memorize or keep in your mind as you work with k nearest neighbor. So now let us turn our attention towards the diagram that you see on the right side. So here it is a kind of 2-dimensional plot, x-axis, y-axis. So here you have the initial data, new example to classify. That is a small yellow colored box with a question mark. So now we have to decide to which side it should be classified. See here you have 2 classes, one in red color and one in green color. So that is why the notation is given as class A in red color and class B in green color. So what happens with respect to the box, that is that yellow colored box that is present with a question mark, we try to calculate the distance of the nearest neighbors. So as you could see, the yellow box is being connected to the nearest neighbors by dotted line. So you must be able to see now it has got connected to 3 at 3 on the upper side, on 3 data points which are above that and 3 data points below that. That is, we just talk about the neighborhood. It is not the question of whether it is above the point or below the point. We just look around the nearest neighbors. So as you look into the distribution of data, you can see it has chosen the nearest neighbors. So then, So they calculate the distance. The second diagram illustrates how the distance is being calculated by selecting the nearest points. So then finding the neighbor and voting for the labels. So what happens here? Now k is equal to 2, that we have to understand, because we try to take the nearest neighbors as 3. So then it has to like calculate what is the distance of this particular data point in question, data point in progress. Then it tries to calculate the distance, for instance, using Euclidean distance. Then it must be able to decide to which side this point has to be placed. That is done by means of finding the distance. Then it finds the neighbor and it votes for the label, and accordingly this point will be decided on with respect to red color or green color. So let us go to the next slide. So this is about the merits and demerits of k nearest neighborhood algorithm. So what are the advantages? Training phases faster in comparison with the other classification algorithms. As you must be able to recollect, it doesn't work on the assumption. So the training is very simple. It doesn't require much amount of time. So training of a model is not required for generalization. When you want to generalize this for any other kind of problem, when you want to apply this for other domains of problem solving, so then training of a model is not required when you want to generalize it. So if you are going to develop a model for a special kind of application, we go for training. If you want to develop a model which is to be as general as possible, when you want to generalize the model, so let us not work on the training. So then it's a very simple algorithm. As you could see, you take a point, then you find the distance, and then based upon the distance, you decide, you vote to which side, to which group probably this particular data point has to be assigned with. So it just goes in a very simple manner, and the workflow is very simple to work as well as to understand. So simple algorithm to explain, understand, and apply, interpret. So the accuracy that is exhibited by this model is amazing, right? It's quite promising. So higher accuracy, and then it is pretty good or high, but not competitive in comparison to better supervised learning models. Like suppose when we talk about supervised learning models, probably we may say that this may not hold good, but as we talk about the kind of unsupervised learning, because this k nearest neighborhood comes under unsupervised learning, because it doesn't work on the assumption. So in such cases, this is able to produce high accuracy. Then this k nearest neighborhood is highly useful for non-linear data. See now, suppose if the data happens to be non-linear, and if you try to apply the kind of a support vector machine, we have the problem of converting this non-linear into linear. Only then we will be able to draw that hyperplane. But in this case, it is not so. And you can just take the non-linear data set as it is. We may be able to apply this and get the best results. It's highly versatile because it is useful for classification as well as regression. But what are the demerits? The testing phase is slower and costlier with respect to the time as well as money. Because we have to take all the data points, that those data points are to be stored in the memory all along. In addition to that, we are going to go for the computation of another value called the distance. So we have to store those distant values again in the memory. They have to be sorted, and then you have to identify the best possible neighbor. So because this kind of computation goes around and you need to store a lot of intermediate values, so this method speaks on the memory and the computational time. So naturally, the computational time will be. So then. So then what are demerits? The testing phase is slower and costlier with respect to time as well as money. Then it, as I told you, it requires high amount of memory. So it requires large memory for storing the entire training data set, as well as we have to go for, we have to look out for storing the intermediate values as well. So the scale uses the Euclidean distance between two data points as well as at the time of finding the nearest neighborhood. So it is very interesting to note that this Euclidean distance is the one which is quite sensitive to the magnitude of the values that we calculate. So as the magnitude, suppose it is quite possible for a problem to give rise to a lot of negative numbers as well. So the numbers with negative magnitude. On such cases, then probably like when you go for storing them again, it becomes a kind of overhead. So Euclidean distance is sensitive to magnitude. So this Euclidean distance is sensitive to magnitude. So this feature, the features with high magnitude will weigh more than the features with low magnitude. So like as we store the numbers, which are obtained out of the computation of Euclidean distance. This is obviously an overhead, we understand. So because this is going to speak upon the memory requirement. So because of these disadvantages, when the size of the data happens to be very large. So for large volume of data, for large dimensional data, this is proven to be not very appropriate. So we do not recommend, we don't opt for this k nearest neighborhood algorithm when the data size is very big and when the dimension of the data is very large, right? So we stop at this point and later we will continue with optimization. So happy learning.